Hello, B's and G's. Welcome to the drive-thru, sponsored as always by the deli. Hungry? Stop by the deli. Get yourself a nice salami sandwich with Colby Jack cheese on some light Jewish rye. Alright, so today's problem is the number of squares on a checkerboard. So to begin going about this, since there's probably not going to be a rule that's just going to pop out of us, we're just going to start counting and making a chart and see what we can gather about this problem. So let's start with probably the simplest of the number of squares on the chart. We're going to start with the squares that are 1 by 1 square. There's 8 on this side and 8 on this side. 8 times 8 is 64. We know there are 64 of the littlest size of squares. Now the reason I wrote 8 down is because 8 is our position number. There are 8 positions on either the rows or columns that could be a square. And it might seem like that number doesn't really do anything now, but later in the problem we will learn that the position number is important. So now we can go about our 2 by 2 squares. And they are a little harder to count because we have to go through and there will be a lot of overlapping squares. But luckily, we will learn later that we only need to find the position number. So let's just go about the column and find how many different positions of 2 by 2 squares there are on this column. So if we highlight this first 2 by 2 square, this overlapping one, this one, so we highlighted them all, but it kind of just looks like a mess. We can count them. 1, 2 by 2, 2, 3, 4, 5, 6, 7. There are 7 2 by 2 squares on this column, and 7 is our position number. Now, for this one, we're going to actually count out and figure out all of the squares to make sure that the rule that we think might be happening, what might be happening is our position number multiplied by itself is the actual number of squares for that dimension. But we don't know that yet because we've only found 1. So let's just keep drawing through the squares and we'll figure it out. Alright, that is actually correct. There were 49 2 by 2 squares on the checkerboard. Cool. So now we're going about the 3 by 3 squares. I guess we're going to have to just count this one as well because a general rule of thumb, you're going to want to find a pattern probably 2 or 3 times before you establish it as a pattern. So on this particular one, there are a number of 2, 5 specific positions. So 5 is our, just kidding, that was 6. 6 is our position number. Now I'm just gonna keep going through and counting more squares. I did indeed count 36 squares, which means, and we will check in that at the end, that the position number multiplied by itself gives us the number of squares for that specific dimension. So filling the rest in, for our 4 by 4 squares, how many positions are there for a 4 by 4? There's this first position, second, third, fourth, fifth. Yeah, just 5. There's this one, this one, this one, this one, and then this is the last one. 5 specific positions on a row or column. 5 by 5 is 25. For our 5 by 5s, there will be 4 and 16. 6 by 6 is 3 positions and 9 squares. 7 by 7 is 2 positions and 4 squares. 8 by 8, 1 position, 1 square. And we can check at the end. 8 by 8 is the entire grid of squares. It is 1 square. Well, there's 1 on this side, so that's our position number. And there is just 1 square. That's the only square. So at the end, we could check in that indeed that works. And if that doesn't convince you, we can try our 7 by 7. 7 is here, and then we can only make 1 more 7, possibly. So that's 2 positions. 2 by 2 is 4. So cool. That works. So now all we would have to do to find the total number of squares on this checkerboard is add some numbers. We had 64, 49, 36, 25, 16, 9, 4, and 1. 1, 2, 3, 4, 5, 6, 7, 8. Cool, I got all the numbers. Now I added it ahead of time when I was learning about this problem, and there were 204 squares. So, indeed, there are 204 squares on this checkerboard. That is our final answer. Alright, on 3. 1, 2, 3, boom!